In this video, we are going to learn about force, linear momentum, and inertia. So what is force? Force is defined as push or pull, which causes three things. First, produces or tries to produce motion, produces or tries to produce motion. Motion in a body at rest. Second, it stops or tries to stop a moving body. And third, it changes or tries to change direction of motion of body. Direction of motion of the body. Its unit is Newton and it is denoted by capital N, and it's a vector quantity. Now let's discuss the definition. Now we know that force is mass into acceleration, and acceleration is rate of change of velocity. Okay, so if there is force, there would be change in velocity. Okay, which means that force causes acceleration and acceleration causes change in velocity. Now when the velocity changes, a body which is at rest will start moving, because initially its velocity will be 0, and when it changes it will not be 0, so it will start moving. And for a body which is already moving, force can bring it to rest or make it velocity 0, and velocity also changes when the direction changes. So apart from changing the magnitude of velocity, force also can cause the change in direction. So that's why we have defined force as a push or pull, which causes a body at rest to move or a moving body to stop, or it changes the direction of motion of the body. Now what is inertia? Inertia of a body is defined as inherent property of all bodies by virtue of which they cannot change by themselves their state of rest or of uniform motion along a straight line. So if external force is 0, then ma is equal to 0 implies that ma is equal to 0 implies that if mass is not 0, then acceleration is 0, which means change in velocity is 0. Okay, so if no external force is applied, the change in velocity of the body would be 0, which means that a body at rest will remain at rest, and if a body is moving with uniform velocity, then it will continue to move in a straight line. That is, if the direction also changes, then velocity will change, Therefore, there would be some acceleration, there would be some force. So that's why. And this property is called inertia. Also, mass is the measure of inertia. That is, more the mass of the body, more would be the inertia of the body. For example, a truck need more force to move than a bicycle because mass of truck is greater than mass of cycle. So if we want to move a truck at rest, obviously we would require much larger force than to move a cycle. Or even if we want to move a heavy body, then it would require more force than to move a light body. Similarly, to stop a heavy body, we need larger force than to stop a lighter body. And this property is called inertia. Inertia is the property due to which body resists the change in its state of rest or of uniform motion. We can understand this by using this formula: F is equal to mass into acceleration. So acceleration is equal to force upon mass. So for a constant force, acceleration is inversely proportional to mass. So more the mass, less will be the acceleration in the body for a force. So that's why more will be the inertia, because acceleration shows the change in state or change in velocity, where inertia is the property due to which body resists the change. So that's why mass is regarded as measure of inertia. Two bodies of same weight m, and one is moving with 100 km per hour and other is moving with 50 km per hour, and we have to stop these both bodies in the same distance. So which body will require more force to stop it? Obviously the first body will require more force to stop it because it is moving with higher velocity. Also, bullet fired from a gun can easily pierce through human skin because of the high velocity of the bullet. So apart from the mass, velocity also has effect on force. More the velocity, more will be the force, and the combined effect of mass into velocity is linear momentum. So what is linear momentum? It is defined as the product of the mass of the body and its velocity. So linear momentum P is equal to mass into velocity. The SI unit of linear momentum P is equal to mass into velocity. Unit of mass is kg and unit of velocity is meter per second. So unit of linear momentum, that is SI unit of linear momentum, is kg meter per second, and velocity is a vector quantity and mass is scalar. So mass into velocity, which is linear momentum, is a vector quantity.